But today we begin to speak about this HTTP and JSON. And because I have been looking at your feedback about what you are familiar with from this course, and you know a little bit of some things about these two concepts, I will not pay very much attention to them. I will just say what I think is the most important, and let's see why they are very useful things. So first of all, this HTTP. It's a very common thing that any web developer should know about. It stands for hypertext transfer protocol. And really what it means is that anytime you ask a server for some information, that information is going to be sent and retrieved using this protocol. So it's a protocol. It means that it's always going to be the same. It's a standard. So for transfer of information, and that information will be in the form of text. And hyper, I don't remember why it is there, but it might have something to do with hyperlinks, same kind of concept. But what you have to know from here is that this HTTP is a protocol, it's a means of transferring text information from your computer to another computer, or from your phone to another phone, and so on. And the information will go as text. And there are two ways of doing this. There is this get method, and there is this post method. And some most important properties for each of these are shown here. If you are going to transfer information using this get method, I recommend to use it when you want to retrieve. When you want to retrieve data, when you want to get information from some server, that's why it is also called as get. It can be cached. We will see later in practice what this means. But basically, it means that your browser can remember the request in its bar, almost like a history. And also quite important, I would say, limitation of this method is that it has length restrictions. It means that the text that you are sending cannot be infinitely large. It will at some point stop working depending on server parameters or settings. But it is restricted, so you can only use shorter requests. Now this post, I recommend you use it anytime when you are dealing with sensitive data. For example, you have application that is sending username and password to your database, and that username and that password is sensitive information. You might want to use this post method in that situation. It is never cached, and I would say two classes here, it's a bit more secure, so we will see a little bit what that means in practice. And also another class is that it doesn't have these kind of length restrictions as the get system does. Now, using this type of protocol, you can send any kind of information you want. You can send a novel if you want. You can send some structured information. For example, maybe you can think, I want to send to the server a username and password. And then you could make, for instance, a standard, not a standard, but a separation between the two. That, okay, I want to send user Radu, and I want to send a password, which is maybe, I don't know, let's say Mopsy, and then you want to say also the age, let's say 29. So now you made a way of differentiating between these three different objects. You know that you are sending a text, but you are going to teach the computer that, okay, this will act as a separator, and this here is also a separator. You will also have to teach your computer that the first one is the name, the second one is the password, and the third one is the age. So these are very common problems that are surprisingly common nowadays. So the problem here is you have to decide one of these separators. You have to decide the order of the data, and if somebody else is going to implement your code, he will have to learn the same kind of complicated system as here. Somebody else might replace this line here with maybe a column or something else, and it will be a new system. So this is why a standard is important, and this is where JSON comes in. So JSON is a way of structuring textual information. And as I mentioned, it's a standard. So once you learn this one, you can use it to send and retrieve almost any kind of data. You can use it to represent empty data, numbers, Boolean values, strings, arrays, or objects. So this JSON is really, it's not the only way, but it's a standard, means that if I learn it and you learn it and somebody else learns it, then we can all collaborate and work on the same project, basically. Now, third thing here is that it is easy to read. Well, it's not extremely easy to read if we look here, because these seem to be fine. Like the name here is okay, the age here is okay, but then you have maybe places like this where this text is split on the second line, and you have difficulties seeing that, okay, this means brown. So it's possible for human to read. A little bit difficult, but human can read this text. But it's also possible for computer to read this text. So this JSON has the benefit of being able to be read by the computer, but also be read by this by the human if I try. So I could understand from here, if I look very closely, that okay, the hair attribute has a dark color, or the eyes are brown, or so on. And the final reason why we talk about this JSON here is that it has a lot of support. And by that I mean that JSON actually stands for this JavaScript object notation. And you know you have support when it has the programming language in its name. So it was meant for JavaScript. It has implementations for all the other major programming languages. But since we mostly focus here on HTML, JavaScript solutions, you don't need to import anything. Your web page will automatically know how to understand this language. That's why it becomes so powerful tool. Okay, now I'm gonna go back to this example here, this text example, and I pasted here a web link, this JSON parser online something. If you want, you can Google for JSON parsers. You probably will find many different ones. the one I use is here mentioned. It's the one from the course slides. And I'm going to copy this text here that I said it's a little bit difficult to read, and I'm going to paste it here in the left side of this parser. Now, what happened here is that on the right side, it looks a little bit more neat, more tidy, in the sense that it's not anymore split on different lines, and humans can read this a bit more easy. And we can look to see what kind of data types are here. So this is an object, and you can recognize it by this kind of curly brace formatting here. I'm going to open the object, and I'm going to look at the different properties. So this is the name property, and it's a string. It has this quotation marks there. The h value, this is a number. So I mentioned before that different data types can be represented in JSON, and this is just an example of how this is done. This present attribute means that I'm here. So I'm either here or I'm not here, so this is a Boolean data type. And now this features, this is another object. You can notice it from this curly brace here. So it's another object, and it says some of my features. It says here the height, assuming it's centimeters. The weight, I'm not going to tell you that, so it's empty for the moment. Okay. Yeah. Here, again, this kind of string data type, eyes, okay, eye color, basically. So this is an object. All these features is an object, and you see I can close it here in this parser, in this online parser. It's very useful if you want to read these very large JSON strings and you want to understand them. I recommend using this rather than looking here and trying to understand from the raw text. And the last one, it's an array. So you know it's an array because it starts here with right angle bracket, I think it's called. I'm not sure what this is called then. Anyway, so it starts with that. It means it's an array. And here it says that I'm wearing a shirt, pants, and slippers. So this can go on as long as I want it to go. And the array items here are strings. But anyway, this is just an example of how JSON can be used to represent all the different types of data. So if you would like to send this type of information to a server, then the server will be able to understand that this is the name of the property, and this is the value of the property, and this is a string, this is a number, Boolean, and so on. So it's a standard. Other standards, XML is a very popular standard. It's also able to do, I would guess, almost all of these things. It may look a little bit different, but I chose one of them, and you will see that this one is very popular. It means that different services like Google Maps or some routing services or weather services, some of your projects is about this weather app, they all support this JSON format. So I chose this, and we will practice using it. Okay, but now I think we move on to really see how is it useful and how to do these HTTP requests and how to write some JSON there. So I just paste this raw text there. Oh, sorry. Yeah, added a new line by mistake. So now I have this str variable, and it contains the raw text that we have there. So how can we understand this? Because at the moment it's still in string format. To parse it and to get the actual properties of the object, you write JSON.parse, and I'm going to give it a parameter, this big string from here, this long string, and I type enter, and now I'm going to read the value of this object. So you can see that now it's no longer a string. It has different properties here that I can click and I can analyze. For example, the name is this string here. The features are shown there. It's an object, and now this array is this clothes it's an array here. So, and it has three different elements. So using this JSON parse, this is part of the HTML and default JavaScript, so I'm not including any libraries to call this. I can already understand this object not just as a string anymore, and I can even modify its properties. For example, I can say that the name of the object should not be Radu, it should be Hilal. So now if I check the property of the object, it changed. It still has my other features, but the name is different. Or if I want, for example, to get the object's clothes, so they are still there, okay? I could say bracelet. Okay, he has a bracelet. So something like that. I'm going to add another item into this object, and now analyzing it, it's updated. So very easy, easy to work with these different objects. And if I want to make it a string again, so new string, this can be done by calling the JSON.stringify method on the object. So very simple back and forth conversion. And if I now check the value of this new string, it's going to be a string again, but now it's going to have the new information inside. So very easy to get the object and modify its properties and convert it into a string again. Again, you need the string when you want to send it somewhere else. If you want to send it somewhere else, you prefer the string format because this hypertext transfer protocol works with strings. So, yeah. And we are using JSON because it's a standard. So not to come up with our own solution that reinvents the wheel, we use this standard system.
Can you do with some tables and text formats or something?
Can you repeat?
With the tables.
Tables.
Yeah.
Well, a table is a matrix. It means an array of arrays.
Mm-hmm.
So if you think about it, a matrix of 3 by 3 would look something like this: 1, 2, 3 on the first row, 2, 3, 4 on the second row, and 3, 5, 6 on the last row. So this is a matrix of 3 by 3. You can use JSON to define it if you want. So yeah, it's possible to define tables here. And because you have also a possibility to add strings, you can have a table with names or anything really. So it's quite a generic solution. Yeah. Okay. Now let's look what my file here has. So this HTTP handler JS file, I already come here with two functions that I tell you will do the GET and the POST request. So I mentioned before that this HTTP requests, there are two of them. One of them is this GET request and the other one is a POST request. So now we will experiment to see what they really do and how they are useful. I'm not going to go into detail about how these functions were implemented. They are very standard, I think so. But you can look at this file if you are interested. I will only point out a few small differences. So, because I wrote this HTTP GET and HTTP POST functions here, if I go back to my console, I'm going to clear it because it has too much text there. I have access to them here. So yeah, so this HTTP GET function is there, and it has a URL as the parameter here. So out of curiosity, I'm going to put the URL of our, let's put the main course page, this one here, to see what the result is going to be. So I'm going to write HTTP GET of the URL of our web page, right? I'm going to press enter and something red is here. And something yellow is here. So many colors. Let's focus on the red first. So this is HTML, a typical HTML page. It has a YouTube video there. Different properties, something about Kuopio, something about Joensuu. So it's basically the information from here, from this web page, in text format. So nothing too fancy, but we use this HTTP GET method to get it. Just to make things a bit clearer, I'm going to write here in the body a div. I name it content, and I just leave it empty. I'm going to refresh now this page, so the div should be there, and I'm going to write the same HTTP GET function, but I'm going to put its output, its result, into that div. So basically, document get element by ID content will get an inner HTML of whatever this HTTP GET function is going to put there. I'm going to type enter, and basically I just populated this empty web page with our main web page by reading the content from another address. So it really contains all the information from that web page. Now, this is a warning here. It says something a bit complicated. It says this synchronous request is deprecated because it's detrimental effects to the end user's experience. Yeah, so what that means is that this HTTP GET function, I'm going to call it with a URL, okay? And until I get the response, until I load this web page, all my interface will be blocked. My interface, all the buttons, I won't be able to click on them. The interface will freeze until all the content has been downloaded. Now, my web page here is quite small. It's not very big, and it's also on the server that is here in this building. So when I press enter, you maybe don't notice it, but I notice a few milliseconds delay before this text is printed here. So there is a delay before that script is happening. If I would load a huge web page or a huge amount of information, it's going to be longer and longer. So this warning here means there are better ways to do this that don't block the interface while the large amount of information is loading. And that's why I have this another function here, which is essentially the same one as above, but it has this, I named it async at the end. It means that it's not going to block the interface, but what it does is, when it completes and when it gives a status of 200, this means that successful complete, it's going to call another function, this parameter here. So the callback with whatever the response of the request is. So this function is going to not block the interface, but I still need to read its output somehow. The main one, I read the output by just returning the value of the response of the web page there. But here I have to take it and give it to something else, to some other function, because if I wait for it as before, it's going to block everything until it returns. So the proper way of doing this this thing is not to use this HTTP GET function, but it's to use this HTTP GET async function, give the same URL as before. I'm going to copy it again. But now I have to give it a callback, something what to do when it finishes. So I can write here a function that says function, this is the response variable, and what it's going to do, I'm going to say write this response in the console. So console log the response. It's going to be a bit clearer after I demonstrate it. So it's really the same thing, but now this function, the second parameter of the function, is going to print our output, basically, when it completes. And meanwhile, the web interface is not going to be stuck. So, yeah, let's go to our examples and write this function here and give it a name, because that way we can refer to it later. And I'm just going to call it print result or something like that. Okay, and it's going to write out our answer in the console. So if I now refresh this page, I can simply give here our print result function, and it's going to do the same thing. So output here in the console our content of the web page that we are analyzing. So it's the same thing if you call this one or if you call the synchronous method. Both of them will give you the content of that web page, but this synchronous method will also give you a warning. It's possible that later versions of the browsers will not support it anymore. So this deprecation means that it's old and you shouldn't use it. So it's the simpler way of doing it, but the more complicated is not going to block the interface. So it's everything that you should know about this. And the post request is going to be very similar to this get, but I will have a separate attribute here, a separate parameter for the any data I want to send to the server. So if I go back to this console here and I look at my HTTP GET function, if I replace it with the HTTP POST function, it works. It's no problem because this web page doesn't need me to send it anything in order to display its contents. So the post and the GET requests, both of them do essentially the same thing. And I have here also a asynchronous post request. So here we have 3 different parameters, one for the URL, the other for any data we want to send, and the last one is the callback. So again, this callback useful so that you don't stack the interface. You will read the result in another function later on. Right. Okay. So we saw in this example that right, I can read the contents of a web page with some of these things, and I'm going to summarize our findings. So this one, let's call our function a function here, test, and try different things. So this HTTP GET, it's possible to use, but deprecated. It will block the interface. The proper way to do it is to call this kind of a synchronous request. Like this. And to give it a callback function, in our case, the sprint result, when it completes, you will have your answers here in this response variable. So testing GET here. Okay. And the post is going to be the same. So here I have nothing. I'm not sending anything to the web page. I can just retrieve it without any parameters. But here in the async, second parameter is still going to be nothing for the moment, but then when the result is coming, I'm going to print the result. And now I can test these 2 functions if they work correctly. So test GET. It reads the web page once. It should read it twice. Oh yeah, I'm not outputting it anyway. So here it's not writing it in the console. So I'm not seeing it anymore. And then this test post is there. Right. So one last time, testing the GET. So now it's 2 times here, once with this deprecation alert, and the second time begins here without the deprecation alert. And you can also, I delete now the console and test also this post. Same thing. It seems like this post is not getting the deprecated warning, but it's just a matter of time. It will get it soon if they deprecated the GET already. So anyway, these functions here show how to get the information from the server so far. I'm not showing how to also send information to the server. So to do that, to send information to the server, you need to find an API that accepts your requests. So an API that accepts you to send it something to the server. And we will experiment a little bit more tomorrow with different kind of APIs. But for today, I made a very small API of our own. I'm going to paste here in the URL something, some link. I'm not sure if you are able to see it properly. Maybe like this. But yeah. Okay, so it's a JSON string here on the right. This request type, add numbers, and then number A is 5 and number B is 10. So I have a script somewhere on the server, this server PHP in this Llama API directory, and this one accepts some kind of input from me as a developer. To explain a little better, if I will press enter here, it will output 50, because that is the answer what happens if you add 5 and 10. So very basic program I wrote on the server. It reads the input from get or the input from post, depending which one is available, or yeah, and then it parses this JSON string, and it understands, what does he want to do? He wants to add numbers. So then it's looking for two numbers, this A equals 5 and B equals 10. So if you replace here 15 and 100, it's gonna be 115. So basically I made a small program on the server. I'm not going to show you that, it's pointless. But I'm assuming that you don't know how to add two numbers. You can ask me. You can ask this code. You can write a function that adds numbers, and instead of doing the normal addition, you can always ask my server to do it for you. Of course, this is a simple example, but why it's important to learn this is that it's a most basic way to send information to the server and to retrieve information. And now your goal as developers is to look for APIs that do more complicated things. So once you have this basic kind of input-output communication, look for servers that do very complicated things. So tomorrow we are going to try to look for these things, see what is free to use and what kind of features we can get in our applications. Just to give an idea, we will give our coordinates to some service, and we are going to get the weather information for that location. So we have a service that has a huge database, complicated models for predicting the weather, maybe even people that are meteorologists and are inputting their data manually. So a lot of complicated things are done by that server, but we just ask it for this kind of information and retrieve the result wherever we are. Other things are going to be about routing, maybe, so to find navigation from A to B using the road network. Again, this is very complicated, because if you don't rely on some external server, then you are going to need to put all the roads in the world on your mobile phone, which is not feasible. So, yeah. Any questions about this? It's quite basic lecture today, and it's yeah, maybe a bit boring compared to the others, but
no, nothing is boring.
Okay. Okay.
Could you please just a little bit show the server?
Yeah.
It's
Yeah, sure. Yeah, sure. We can look. Let's see. So there is this API. So here it's gonna maybe be a bit confusing because I prepared for tomorrow, and I have here this add numbers request. So what I'm doing at the server, I'm reading this param object, either from post, or if it's empty, I'm reading it from get. So this param object is this value from here. After I get it, okay, I'm going to call this function, process JSON request. It's just here at the bottom, nothing too cryptic, and I'm going to decode this string. So this is a string. This value here is still in the raw form as a string. I'm going to decode it as an object. So it's the same thing I showed you how to do in JavaScript, but now I'm using the PHP functions to do this on the server. And then I'm going to process the request with this object. So this process request gets the object as a parameter, and then depending on this request type, which in my case it's add numbers, it's going to call the add numbers function, which, surprise, adds 2 numbers. So a very small thing, but tomorrow we will use more complicated things here that would not be so easy to implement on your mobile phone, and you will get a bit better better understanding of how you can make your application more powerful by using what others are willing to give you.
Why there is the JSON decode function?
So this param object, you can see it's being sent here to the different functions as parameter, and also to this add numbers function. So in this add numbers, I want to get the value of A, and I want to get the value of B to add them up. If I don't use the JSON decode, then this is a string. It doesn't have A and B, it just has semicolon, quotation, R, E, Q, U, and so on. So JSON...
Yeah, there was the JSON format in this column, yeah.
Yeah, so this JSON decode makes this an object, so I can get the A property, the B property, and also the request type as a property. So I'm not parsing that string myself, I let the JSON functions handle it. So it is the same that we did before when we modified the Radu value to Bilal and different things in JavaScript, but here I'm doing it in PHP, basically.
Yeah.
Okay, great. So I think we will have 10 minutes break, and after that we go back to Android. So we finish our task from last week, and we finish this super tracker native application to get it to the same level as the web application. Yeah, so see you in 10 minutes. Okay, I think we can go on. And I forgot to do something before, so I'm going to still do it now before moving on to the Android. I modified a little bit the HTML page that we worked before. So now it has 2 input fields, this field called A, this field called B, and a span for the result, and a button that calls a function called add numbers. So coming back to the main page, it looks now like this. It has 10 here, 15 here, and an add button. So just basic HTML. And this button calls a function called add numbers. I also wrote the function for add numbers that sends to that link that I showed before, that I made on the server, the request type of add numbers, and it gets the value of A and the value of B from the HTML page, and it calls to the server using this asynchronous post request. When the results are ready, it reads them, it parses this JSON output, and it's going to get the value from the server that the server returns, and is going to put it in this result field. So essentially what I want to show is that now when I press this add button, I'm going to add 2 numbers without having the plus function in my code. So it's just calling the server to do that, and the parameters that are sent to the server are being retrieved from this kind of these input boxes. So study this code update that I did just now, and learn how it works. It's quite basic. It uses the JSON stringify and this JSON parse function to communicate with the server and send different values and also retrieve different values. So yeah, I updated it. It will be in the demos page there. Also for Kuopio, if somebody was not there, I made a small modification there, so you can check the demo after the lecture for the source code.
Thank you.
But now, moving to Android. So let's see where we were left off. Last time I'm going to debug this app in the emulator. And last time we were here, we had this Superman logo there, and if you remember, we have this possibility to move him to some specific location that we define here, or to have him follow a trajectory that I previously loaded in this GPX format. So he was moving around the map and also rotating according to the direction of movement. And what we have to do now is add the controls for starting and stopping tracking. Essentially, I'm going to close this for the moment. And I wanted to get to the level of our web API. So we have also this HTML5 API, and this one has different controls here that allow you to view a route collection and to start and stop tracking, save or delete the route. So these functionalities are missing now from our native application, and that one is now here. It has a slightly different icon from the first one. So let's see how we would do that. If we head back to this activity maps, the text here is only going to create our map object. So we need to create a map object, but also to create some additional things there, the buttons that will start and stop and so on. So to do that, I'm going to create something called a relative layout. It's not maybe the best way to do this, but I tried to use some objects that will resemble very much our HTML5 application. So we want to mimic that one as much as possible, so they are still comparable at the end. And this relative layout is now going to contain our map fragment. And so far it contains just that. So if I go back to our design view here, it still has this map fragment there, and no change. But what we can do now is that we can add more components onto the screen. So I'm going to add, first of all, something called a table row. This will have the ID of start tracking controls, so it's the same ID that we used in HTML5 for the start tracking controls. This contains the start button and the collection button, so the two main buttons that we see when we open the application. And here they are now visible on this bottom side of the screen. So just two buttons. It is the same strategy that we used on in HTML. And the properties are a little bit different, how this alignment works, but essentially they look pretty much the same as they did in HTML. And to save time, I'm going to paste the rest of the buttons. So if you remember, in HTML, we had everything visible at the same time. That means the start tracking controls, the stop tracking controls, the publish controls with the saving and delete buttons, and the collection controls that were the left and the right, which are useful to pan through existing collection, and the back button. Now, a bit similar, but not exactly the same as in HTML. These buttons here now are overlapping each other. In HTML, the way that the page was rendered was pushing them down or up, and you could still see all of them at the same time, but they were not overlapping as they do here. But this will not be a problem because we will not show all of them at the same time. We will only keep visible the buttons that are supposed to be visible when the application is running. So next we will go to write our functions that are starting the tracking and saving the tracking and looking through the collection essentially. Right, so that's about the layout. This is equivalent to the HTML page that we created in the file file. Okay, and now about the controls. So I will remind you a little bit that this maps activity is our main activity, and this onCreate function can be considered as a main function. It was checking for location permissions and instantiating this location handler. So this is what we did last time, and also instantiating our root object. The root that we record is going to be empty, an empty array list, and the collection is going to be an empty array list of roots. So this list of lat, lng is corresponding to the type of the root object. And what we need now is to write controls for those buttons that we defined. So I'm going to make a class for controls. And essentially what we are going to do here is assign the controls similar to the way we did the on-click handlers in HTML5. But we need to do this in code. And it's going to look something like this. I also remind now that any errors that appear here are most likely caused by not including different packages. So for example, not including the button class here. So this IDE, the Android Studio, helps you very much to do this. And then, oh, sorry, I should have made a different function here. Add event listeners. So now I want to say in this function that the button that has the ID of start should get a function when being clicked, so it has an on-click listener, and here I'm going to say what that function will do basically. So let's just put a placeholder here, start tracking. Okay, and I need to access the root page, this maps activity, because that is where the button is defined, is reachable from this find view by ID object. So I need again the similar owner object that we used beforehand. So our constructor, it's going to have parameter from the maps activity, and we will need a variable here where we store this value. So private is just enough because it's going to be accessible only in this class. So when the constructor is instantiated here, I'm going to set the value of this variable to the value from the argument, and now I use it to access the elements from the main page. Okay, and this placeholder function is something we need to add. So just in case it's a bit confusing, this start button from here is the one from here. This okay, the text view in the start tracking controls, the start button. So that one, when pressed, is going to get an event listener for the click event, and then we need to fill in this function. It doesn't exist at the moment. To save time, I'm going to add the other event listeners. So these are all other event listeners that we will need. We have one for the start button, we have one for the collection button, where we will view a collection, the stop button, the save, the delete, and panning through the collection, this left and right buttons, and the back button to come back to the main page. So now we need to define these different functions that are going to make our application work. And I'm going to do this here in further. I think I'm going to paste them and we will look through them, because they are identical, nearly identical to the ones that we did in HTML5. So I kept the same naming of the functions, and you already have an idea of what they do. So I pasted it, and I'm getting some kind of errors here that I still need to include some files. But let's see what we have. So if you remember, we had this init controls function. It was hiding all the controls on the screen, but then after you hide it, you were still showing the start tracking controls, because those are the things that are the main screen of your application. So I'm still putting the start tracking controls to visible after hiding, and these values here say that you are on the main screen, so this screen variable, and when you're returning, anytime you're returning to the main screen, you want your root value to be empty, because it either means you're starting the application or you are coming back after saving the root in the database or after deleting the root. So you want to reinitialize this root object. Now I'm importing this lat-lng object, which is not used here, and this array list is also not defined. Hide all controls, it just gets all the elements, all these different controls, and it makes them invisible. So very similar to this hide show functions that we wrote in HTML last time. The start tracking function, first of all, maybe here, it hides the controls, and then it shows the stop tracking controls. So once we start the application, we need a way to stop it. So the stop button has to become visible. And also the screen, the value of the screen is going to change to the tracking. This will be useful later to record the route, not just only the points that are updating when tracking is on will be part of the route. So this screen will help knowing that. And then stop tracking, it's going to turn on the publishing controls. So these ones become visible. Basically, then you have two options: save tracking. We add the route to our collection here if it has at least 2 points. So if it doesn't have 2 points, then it's not a route, it's not a trajectory. It needs to have at least 2 points. And here I commented out from HTML this set cookie function. If you remember, and I secretly used JSON even though I didn't describe then how it worked. we won't be able to use cookies here, so we will need a different solution for storing the values. But meanwhile, this is like a placeholder for saving. Saving is not yet implemented, so we will add that a bit later. And for delete, it basically is the same as the save tracking, but without the saving. So delete is just reinitializing the controls. It's going to lose the route that was tracked, and that's it. For the collection, we move the screen to the collection screen, and we show the collection element 0, means the first route that is in memory. We are going to display that element, and after hiding the controls, we are going to show the back control and this left-right control, so these become visible again. And looking now at this show collection element, given an index, it's going to do a couple of things. It's going to put some text there showing which route out of the collection size, so how many routes we have, and telling us which one are we looking at the moment, and displaying it on the map, so putting the points in the polyline coming from our collection, so the one that we have so far. And then this piece of code here is a bit annoying. I thought that this is easier to do here. What it essentially does, it moves the camera to the boundaries of the route that we want to display. So we get the points of this thing that we just made visible, our route in question, and we tell our camera to update it to the bounds of these points, and we had to calculate the bounds here. So this bounds builder object creates your bounds for a route. It's, I think, good support from the API, but it could have been much easier, I think. Yeah, so I think Google could work a little bit on making this part more easy to do. And I'm going to import now these camera handling functions. Oh yeah, and if the collection is empty, so if the collection doesn't have any items, I just show the text empty there. So this is, yeah. And to move the collection left and right, I just increase or decrease this collection index value, and I show the element from the collection index. So it's, if you have paid attention to the HTML code, then the names are the same, and the functionality is almost exactly the same. So trying to mimic what can be done in HTML5. Okay, so this controls class is going to help us do the different actions when pressing the different buttons, but we have not called it anywhere. So going back to the maps activity, maybe here next to our location handler, I'm going to write a variable for our controls. Okay, and these controls need to be initialized somewhere, very similar to the way we initialized our location handler. Maybe I do it here when after we empty these, after we define the route and the collection objects. So I'm gonna copy this here. Basically, I'm telling the controls to initialize, and I'm giving here the property of this. So this maps activity, here is where this owner value becomes instantiated, and I can still access the maps activity through its value everywhere to get a hold of the different buttons there. And then I'm adding event listeners for all the buttons, and I'm initializing the controls. This means that I only show the start and the collection controls at the beginning. So let's try to debug the app with these changes now. Okay, and I'm going to put this guy to move according to this recorded trajectory that I had there, and then that it doesn't seem to be moving very much. I think that, yeah, this trajectory has a stop point here, so I was waiting for somebody at this location, and while waiting I wasn't moving much, so now I'm waiting for him to start moving in some other direction to be able to test better. So okay, I think now he starts to move. So start and collection buttons are there. If I press the start button, it should start. So now the polyline becomes visible on the map, and the root object is starting to form. And when stopping, now this functionality should stop. So I now have the save and delete buttons that are visible, so very similar to the HTML value. And I can choose to save or delete it, but anyway, the new root is in the collection. So let's try to record another root as he is moving. So I started the app again. This is just fine, so I'm going to stop it again, save it again, and go back to the collection. So I'm pressing now the collection button, and we have one root here, the first out of two, and pressing right, the second root is here. So left and right pans through these ones, and the back button goes back to the Superman where he is moving and appearing on the map. So this is almost the same functionality as before. We are still missing the save function, and by that I mean the persistent save function. If I close this app now, it's not going to remember these two roots because they are just in the memory of the app. If you remember, we used cookies in HTML5 to store them. Even if you leave the page, you can still keep them in the browser's cookies and then load them when coming back. But now we need to find another way how to do this in Android. So just to demonstrate, I'm going to close the app and open it again. And once it's loaded, when I go to the collection, it's empty. So it didn't remember those two roots that I just recorded. So this is one thing that I still want to implement. And then I think it has similar features as the web application, and we can look a little bit at both and see how they differ. Right. So for saving and loading, I think it's also best to just copy and paste some functions and talk with them later, because otherwise it's going to take unnecessarily long. I just keep the maps activity and I add the functionalities here at the bottom. So under this on map ready, I will paste a couple of functions. One is try to load collection. So this is going to try to load collection from somewhere on the persistent memory of the device, and another function for saving the collection. Now, before we look how they work, I want to also add them. So when we open the application, here we say that our collection is empty, is initialized as an array list. So this is where I'm going to say that I want to try to load the collection. So I'm going to try to load the collection. If whatever this function does fails, I still have the empty list there. So it's kind of a safety precaution. right? And to save the collection, this one, I'm going to call in the controls where we had that cookie placeholder there that we still haven't figured out at that point how to save it. So now I'm going to call owner save the collection, and I don't need this placeholder anymore, so I just remove that. But let's see how these functions work. So try to load the collection. Okay, let's look first at save the collection. It goes through all the elements in the collection and it takes them one by one. So that means that I here iterates through the different routes that we might have. So if we have 10 routes, then collection size is 10. And for every if route, I will form a JSON array. So now you already know what this JSON is, and you also see that it has the support in Android, so not just in JavaScript. And this JSON array is going to be empty at this step, but then I'm going to add point by point the different values of the route. So the ith route in the collection, I'm going to get every jth point here. So this is every point in the collection, and I'm adding its latitude and longitude in this same format that we used to store the cookie before. And I realized that we are missing here timestamp, but yeah, so code should be updated to keep also the time of each point, because with time you will get also the speed information later on, and if we lose that component, we can't get it. But yeah, so far very similar. So every route is going to be a JSON array, and we are going to store every route in this bigger JSON array. So array of an array of points means array of routes, basically. So a route is an array of points. And we are sharing them in something called shared preferences. So this is something that Android has for each application. It has a memory region where you can put different values that will exist even after you restart your application. So that way we are not losing our route information if you close your app. So in this shared preferences, we need to give a name for this file. I just gave this my preferences file, and this mode says that other apps can't have access to it. So it's also possible to have preferences that may talk between applications. I'm not positive, but you can think about it like this Messenger application from Facebook and the actual Facebook app. They might have some things that they would like to have in common, like maybe number of notifications that you get in the chat messages should be a common resource. So then that could be, probably uses this, but I'm not 100% sure. So then simply putting the value of this all the routes as a string into the shared preferences, and that's it. The try to load collection just reads whatever is in this myprefs file and tries to parse, does exactly the opposite direction, but we don't have a parse function in the same way that we have in JavaScript. And the reason for that is that JSON is able to do many things, like represent strings, represent numbers, represent Boolean values, and so on. And JavaScript is not a very strongly typed language. It means that you can just write var in front of a variable, and then you can put anything in that variable. You can put strings, you can put numbers, you can even change one after the other, and somehow the language adapts. But Java is much more strict than that. So here we need to specify that, hey, you are working with double values for the latitude and for the longitude and so on. So because of that, our functions become a bit more bulky. But essentially, I'm reading the JSON values from the shared preferences and into the collection object. And if it fails, it just fails. It will print an exception, and my collection object will be empty, but the app will still run. So yeah, so that's why I call it try to load collection, because at least in the beginning, when there is no collection, it will fail. It will not find anything there, and it will be empty, so that the file won't exist, or the collection will be empty. So that's why it has the word try there. So let's see how it differs now. Okay, so collection, it has, well, how does it have the roots again? I think it's possible, I didn't close the app. I just opened another instance of the app, or let's try again. So no, I'm wrong. The collection is there. They are other roots. They are not the ones that I recorded before. They are different ones I tested before the lecture, and I recorded some things into this file, into this shared preferences, and now it just loaded whatever was there and displays to us. So a bit confusing. I didn't think about it like that, but let's try to record more of them. So this route that now goes across to the river for some reason. Oh yeah, it's this. It's not really a river. It's just a very small stream here. So I stop it. I save it. Going back to the collection. So first two different routes, and the third one is now our new addition. And I close the app and I open it again. And collection has also the third route now, so this shared preferences are updating with the new information. So let's see what we have. This app, and compare it with the HTML5 app. So I'm going to use the last 10 minutes to have a few notes about how they are similar and how they are different in feature-wise. First of all, it's empty, so it doesn't have any other functionalities than this Google logo here. It's the only thing that is blocking the map. If I press the Google logo, nothing happens. If I move around the map, it's possible sometimes to get some objects like this Botania garden here. This seems to be something that Google adds on top of the map, but if I click it again, nothing happens, so it's not disturbing me in any way. And if I pan to the left or I pan to the right, the map just continues to add different tiles. Also, this possibility to rotate the map. So this is something that we have here in the native app. And then the collection, you see these routes that are loading every time I press the right and left buttons. They are working just fine. Now, this is a bit different from the HTML5 app. So let's demonstrate also that one and see how it's different. A little moment there where all the buttons are visible, that could be handled. But by default, we have this kind of screen here. All these different functionalities here, like the map view. This is something you could add, but you have to do it specifically. The map doesn't let me rotate it the same way as the native map API lets me rotate it. So this is one functionality that is missing here. These buttons seem not to behave. Well, some of them behave. So maybe while you try to pan the map, you have this kind of info box appearing. It might be something that interferes with your usability. So you might just want to drag the map, but then something appears in front of you. Something you need to either tell Google stop doing that, but I'm not sure if it's even possible to do it on all the objects. And then this Google value from here, it opens Google. So a little bit of worse user experience caused by these other functionalities here. You have the street view, you have these plus minus buttons. We can hide those. So these buttons from here and these from here could be hidden if we don't need them. The main thing is just that they use space, and your screen is small. On the mobile phone, you really want to use as much space for the necessary as possible. And using Street View on a small device is not useful, so taking it out would make it more similar to the native application. And now the collection is empty, but let's try to do some route recording with the HTML5 app. I'm going to save it, and I'm going to start it again and record another route to see how this is different. Let's say that this is good enough. And going back to the collection, the route is missing. This is a bug. If I zoom out a little bit, then the route appears again. This is a problem that the browser-based Google Maps needs again to be taken care of separately. And there are tricks to make it work, but it's not as easy as in the native, where it kind of works more smoothly. So yeah, sometimes it works here, like now it showed the route a little bit, but now it disappears again. Okay, now it's back. Now it seems to work just fine. But sometimes it causes, like now. So now the route is missing again. I'm not doing anything wrong when writing this code. It's just a small bug that the JavaScript API from Google is not working as expected. And yeah, so it's a bit more difficult to get as good application in HTML5 as you would get in native. You need a bit more this kind of bug fixes and hacks to get it to work exactly the same as that. And lastly, I think it's quite a big lack of functionality is this marker here. So if you remember, this marker is now rotating just because I drew this Superman icon in 8 different angles. So I drew him at 45-degree angle offsets, and I replaced his angle to be I replaced the picture to fit the one according to the movement, but in the native API there was a rotating function there. So basically I just told him to rotate it as the direction, and then no need to do any of these hacks. And he also rotates at less than 45 degrees, so he can rotate at any angle. So the functionality is just a little bit smoother here. There are a few other changes, but what I will do for next time, I will try to add some of the fixes into the HTML5 version to get it a bit more smooth, a bit more similar to this native. And I'm going to comment, so I don't use many comments in the code because I try to keep the functions clean and small, so it's kind of easy to read without them. But now for these glitch fixes and this special functionality that gets the apps to be more comparable, I will add comments. So anywhere where you will see comments, it means that I tried to make it more similar to the other. But I won't have a lecture about this, so I will just make the updates there. And you can look at the source code if you are truly interested, but I will not evaluate you on this, or they are not necessary to know. They are just some small things that make it even better. So if you are interested to learn, then just look at the source code after tomorrow for the HTML5 app, and that will be the code will be there. Yeah, and I think we will talk at the exercises more about these apps, and we will still continue to develop them. Tomorrow we will add some new functionality to them that will come from these server-side APIs. I might stick to one of them, maybe the HTML5 or maybe the native one. I think I will just check how many of you guys have HTML5 projects and how many have native, and I will stick to one. And then when I update the code in one, I will update in the other one also, but offline. So you can still get the updated source code, but I will not show how to do it in both because it takes too long, and the essential is here. So the rest of the things, it's just going to be a fine-tuning of what we already have, and with the addition of what we learned today about the HTTP requests and JSON. So that's everything.